Saxon's Calculus, Lesson 14, is about the logarithmic form of the exponential, base 10 and base e, and then simple logarithm problems. So in part A, the logarithmic form for an exponential, if you have n and a base of b and l as its exponent, they're saying that is the same as writing the word log and keep the same base of b as you have in the original, and the equal part is the large number sitting beside it, and then it equals whatever the exponent was. And that's the rearranging back and forth of the log to an exponent format. In example 1, it says write 4 equals 3 to the y in its log form. So log has a base of, keep the same base of 3, the equal number goes beside it, and then it equals the exponent. And so you've rearranged that to the format. They don't want you to solve it or do anything else, just put it in that form. Now, there are two basic common logs, which means the word log implies a base of the number 10, and natural log implies the base of e. And you learned this definitely in trig class, and you've got these buttons on your calculator. The only thing confusing is that natural log is written as ln, not nl in your calculator. It's just one of those things. Example 2 says write 2.4 as a power with a base of, and then in A it's 10 and in B it's e. So they're asking you to say 10 to what power equals the given 2.4. So since 10 is the base with a log, if on your calculator you do log of 2.4, you should get 0.38. If for the e, it's asking e to what power is 2.4, because the base was e, you're going to natural log. So if you natural log 2.4, you should get 0.88 on your calculator, and those would be the answers for what the exponent would be. In example 3, they say, what do you get when you do log of 2.4? Well, I just did it. And what do you get when you do natural log of 2.4? Well, we just did it. So there you go, same answer both times. Part C, simple log problems. So now they want me to solve log base b of 9 equals negative 1/2. So let's rearrange it. B to the exponent of negative 1/2 equals 9. All right, so I need to get b alone. It has a negative exponent. What could I multiply this by to turn it into b to the first, because that's what b equals? Well, that would be multiplying it by negative 2. So if I do that there, I need to do that on the other side to keep it balanced. Negative 1/2 times negative 2 is positive 1, so there's that exponent fixed. 9 to the negative 2 means 1 over 9 squared to get the negative out, and 9 squared is 81, so 1 over 81. Example 5. Log base 3 of 1/27 equals 2m plus 1. So again, our base is 3, our exponent has become 2m plus 1, and that equals 1 over 27. Now this looks complicated, but if I can get the bases to be the same number, it will be very helpful. So can I write this 1 over 27 with the base of 3 instead? Well, let me see. 3 times 3 is 9 times 3 is 27, so cubed would work. But it's 127, so what if I make it negative 3? Well, that would flip it to the bottom. Yep, perfect. So now this 3 to the 2m plus 1 equals 3 to the negative third. The bases are the same, so I don't need to worry about them. So that just drops down 2m plus 1 equals negative 3. Ooh, yay, now I can solve for m. So 2m equals negative 4 by minusing 1. Divide by 2, m equals negative 2. Example 6. Log of 1/3 p equals 2. So we rearrange, base is 1/3, exponent is 2, and that will equal p. Oh, I'll have to square that then. 1 squared is 1, 3 squared is 9, so p is 1/9. Example 7, final one. Log of x, 6x minus 9 equals 2, and it has to clarify that x is greater than 0. Because log statements, like roots, cannot have negatives sitting beside them in their whole number piece, they have to clarify that we have to keep it positive. So let's rearrange. X to the second equals 6x minus 9. So let's put that all together and make it equal to 0, because when I see a squared and an x, I want to try to factor that. So x squared minus 6x to move it plus 9 equals 0. Can I split that into 2 parentheses, x and x? Well, 3 and 3 will definitely make 9, and they're both the same number, so let's make them both negative, and then as a double check, negative times negative is positive. Great. So your book wrote that as x minus 3 squared, but either way you're writing it, that's where you're getting to. So the solution is x equals 3, and that answer was greater than 0, so it falls within the acceptable window. And then just kind of as an extra check, I like to throw it in here to make sure I don't get a negative. 3 times 6 is 18 minus 9. Nope, I'm not going to get a negative, so I'm good every test I've got.